Module 3 says 5 teams are to meet around a round table, and each team consists of 2 members and 1 leader. How many seating arrangements are possible if each team sits together with the leader of the team in the middle? So I am a person that I have to see what is going on. So I draw a table. I know it's not round, so let me make it better. This is a round table. The round table, all right? And you have how many teams? They said that there is 5 teams. There are 5 teams. 1 team, 2 team, 3 team, 4 team, 5 team. So there are 5 teams around the round table. Now, generally, to find the number of combinations around a round table, it's going to be equal to n minus 1 factorial. N minus 1 factorial. That's the formula for number of arrangements around the round table. All right, you have to remember that is number of arrangements. Around a round table. Number of arrangements around a round table is given by n minus 1 factorial. Now, in this case, it is 1, 2, 3, 4, 5. So it's going to be equal to 5 minus 1, which is 4 factorial. But when I finish it, multiplied by, we need to look at the different combinations now of how the teams are seated. The leader sits in the middle. So put the leader has to sit at the middle. Well, he doesn't have to, but he wants to. So the leader of each team sit in the middle. The leader here and the leader here. So what that means is that on the edges, one of the person can sit here. So maybe I can sit here or I can sit here. So there are 2 possibilities here. There are 2 possibilities for where this person can sit. This person can sit either here or here. So that's 2 possibilities. And it's times 2, times 2, times 2, times 2. So it's equal to 4 factorial times 2, times 2, times 2, times 2, times 2. That will account for all of the different teams. All right, so you put all of that in a calculator. And so that's going to be equal to 4 factorial times 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 times 4. Getting 768. So just to write it pretty, I think you can write it as 4 factorial times 2 to the 5th power, just to make it easier. 768. So it's equal to 768 ways. So there are 768 ways this can be done. All right, nice and easy. So that's part I. Now let's look at part 2. Part 2 says, in an experiment, individuals were asked to color a shape by selecting from 2 available colors, red and blue. The individuals chose 1 color, 2 color, or no color. It says 80% of the individuals use colors and 600 use no colors. All right, so once they're telling me about colors, no colors, and stuff like that, I'm thinking of a Venn diagram. That's just how my brain works. I like the Venn diagram. You can never go wrong. All right, so I'm thinking of a Venn diagram here with colors, one color, two color, and whatever. And it is saying that one of the color is red, and one is blue. So maybe we can put red here and blue here, and then this would be the two colors. It says 20% of individual use no colors. Because if 80% use colors, 20% don't use no colors, and so 20% of the total amount of students, let's call the total amount of students X. So 20% of X is equal to 600. So if 20% of X is equal to 600, remember 20% is 1 over 5, so 1 over 5X is 600. And if 1 over 5X is 600, then X is 3,000. So that means the total number of students is 3,000. So this is 3,000. That's the total number of students. Now, since this is 3,000, then out here it's going to be 600. Out here is 600. And then it says that means that 2,400 use colors. 2,400 is in here. And it says now, okay, calculate the probability that, given that 40% of the individuals use red. So 40% of everybody use red. So 40% use red. So 40% of 3,000, 40% of 3,000 use red. And so I'm just writing down information given. And so 40% of 3,000 is 1,200. All right. So 40% of 3,000 is 1,200. So 1,200 use red. This is the amount that use red. Now, what else they're telling us? They tell us 50% use blue. So blue is 50%. So blue is going to be 50% of 50% of the individuals use blue. So 50% of 3,000 is equal to 1,500. All right. And it says calculate the probability of those that use both colors. All right. So as you can see, you have 1,200 in total use red. And so if you want to call the intersection N, it's going to be 1,200 minus N. And then in here is N. And then over here is 1,500 minus N. This would be what we have, all right? This is just what represents everything. You want the probability of both. Now, you can do this now, just using this formula, the probability of red intersect blue is going to be equal to the probability of red plus the probability of blue minus the probability of red union blue. And that works out to be the probability of red, which is 0.5, plus the probability of blue, which is 0.4. Actually, I did it wrong, 0.4 plus 0.5 minus the probability of red union blue, and their union is 0.8. How do I know that? Because this together was 80%, all right? And so the probability of red intersect blue is equal to 0.1. So that's 10%, all right? So that is 10% use both colors. So if 10% of everybody use both colors, then this should be 10% of 3,000 is 300. So in here, so should be 300. So if you want to write it, this intersection is 300. And then so over here is really 900. And so over here is really 1200. Now pre this, 900 plus 300 plus 1200 plus 600 is 3000. And 300 over 3000 is your 10%. So that's the answer. 10% use both colors. So this is a set representing everything. That satisfies part A and part B. So answer both our question already. So 3000, this was part B. This is the answer for part B. This is the answer for part A. Nice. Now go to matrices. It says A and B are two matrices. And it says determine the range of values for X for which A inverse exists. So first thing, it tells us that A is equal to 1x minus 1, 3, 0, 2, 2, 1, 0. And so to determine the range of values for A inverse to exist, A inverse will exist if the determinant of A is not 0. The determinant of A cannot be 0. All right, because if the determinant of A is 0, it's going to be singular. All right, so we want where the determinant of A is not 0. Now to find the determinant of A, we can use column 1 or we can use row 1. I'm going to use column 1. So using column 1, using column 1, we're going to get that the determinant of A is going to be equal to 1 times the determinant of going to be 1 times the determinant of 0, 2, 1, 0 minus 3 times determinant of x minus 1, 1, 0 plus 2 times the determinant of that's x minus 1, 0, 2. Nice and easy. That's the determinant of A. So what are we going to get? Now, product of the leading is 0 minus the product of the non-leading. And so 2 times 1 is, that's what? 2 times 1 is 2. 0 minus 2 is minus 2. And we have minus 3 times x times 0 is 0. 1 times minus 1 is minus 1. So it's going to be minus 3 times 0 minus minus 1, which is plus 1, plus 2 times, this looks like 2x minus 0, and this can't equal 0. All right. So solving this now, we're going to have minus 2, minus 3, which is minus 5, plus 4x, and this can equal 0. So what you're ultimately telling me then is 4x cannot be equal to 5. And so x cannot be equal to 5 over 4. But then that don't give us the range. Remember, they wanted a range. So since they wanted range, we just have to tell them that x can either be less than this or greater than this. So x can either be less than 5 over 4 or x is greater than 5 over 4. That's the range. Now it says, given that the determinant of a times b is negative 21, show that x is 3. So find the determinant of a times b, and it's negative 21. All right, given that the determinant of a times b is negative 21, well, I was trying to think of a shorter way to do it, but I'm just going to find the product of a times b. The product of a times b, I know it sounds very long to work out that the product of a times b, that's 1x minus 1, 302, 210, and it's being multiplied by 1, 2, 5, 2, 3, and 4. And this is 1, 1, 2. So the product of a times b, so the product of a times b is going to work out to be row times column, row times column. So AB is going to be 1 times 1. So you get 1 times 1 plus x times 2. 1 times 1, which is 1, plus x times 2 plus minus 1. So that just becomes 2x goes here. Then row times this column is 2 plus 3x minus 1. But the 2 minus 1 is 1. So it's really 1 plus 3x. Then row by column, it is 5. This column becomes 5 plus 4x minus 2. But 5 minus 2 is 3. So it becomes 3 plus 4x. Then it's going to be row by column. So that's 3. Row by column, that's 3 and 0 and 2, that's 5. Row by column is 6 and 0 and 2. 6 and 2 is 8. And then row by column is 3 times 5 is 15. 15 plus 4 is 19. And then row by column, 2 times 1 is 2, plus 2 is 4. That's 4. Then row by column is 4, plus 3 is 7. Row by column, that's 7. Then row by column is 10, 14. So this is 14. This is AB. All right, and so the determinant of AB is equal to, the determinant of AB is now, as the determinant of AB, it's going to be, we're going to be using column 1. I like to use column 1. So it's 2x times 8, 19, 7, 14, minus 5 times the determinant of 1 plus 3x, and then that's supposed to be 3 plus 4x. All right, 1 plus 3x, 3 plus 4x, 7 and 14. Nice. Then we're gonna have, this becomes plus 4 times the determinant of 4 times the determinant of, cancel out this. This is now 1 plus 3x. One plus 3x times 3 plus 4x. One plus 3x times 3 plus 4x. 8 and 19. All right, and remember they said that the determinant of AB was negative 21. So with that being said, let's go ahead and calculate. So now we're saying that negative 21 is equal to 2x times 8 times 14 is 112 minus 19 times 7, 133, minus 5 times 1 plus 3x times 14, that's 14 plus 14 times 3x is 42x, minus 7 times 3 is 21, minus 7 times 4 is 28x, plus 4 times 1 plus 3x times 19 is 19, plus 19 times 3 is 57x, minus 8 times 3 is 24, minus 8 times 4 is 32x. All right, nice. So let's simplify it. We have minus 21 is equal to 2 times 112 is 224x. 2 times minus 133 is minus 266. Then we have minus 70 minus 5 times 42 is minus 210x. Minus 5 times minus 21, that becomes plus 105. Then 5 times 28, that's plus 140x. Plus 4 times 19 is 96. 76, sorry. Plus 4 times 57, 228x. 4 times 24, I'm positive that one is minus 96. Then minus 32 times 4 is 128x. All we need to do is group our x terms. So let's group the x terms. I'm going to highlight the x terms in red. 224, 210, 140, 228, 128x. So putting those together, we're going to get minus 21 is equal to 224 minus 210 plus 140 plus 228 minus 128. That's 254x. Then adding up all the numbers, I have minus 266 minus 70 plus 105 plus 76 minus 96 I get minus 251. Bringing it over, 251 plus 21. That's not giving me, something went off. Let's check again. X should be 3. X should be 3. So we need to show that X is 3. Let's check what we did. Make sure we didn't make any mistake. 2X. That's 8, 9. That's good. Minus 5 times. This is fine as well. Plus 4 times. And this is good. So we checking this now. It is 2x times. This time minus this. All right, let's remove this line and simplify from here. Just going to simplify inside the brackets first. 2x into 112 minus 133 is minus 21. Minus 21 times 2, that's minus 42x. Then I'm going to simplify in that bracket to be 14 minus 21 is negative 7 times minus 5. That's plus 35. 42 minus 28, that's 14 times negative 5, that's minus 70x. Then I have 19 minus 24 is negative 5 times 4, that's minus 20. Then I have 57 minus 32 times 4, that's 100x. Let me see now. Minus 21 is equal to minus 42 minus 70 plus 100. That's minus 12x. Then I have 35 minus 20 is 15. And so when I subtract 15, I get minus 36 is equal to negative 12x. So I divide both sides by 12, and so x is 3. So that proves it. X is 3. All right, so this takes care of it. X is 3. Nice. X is indeed 3. All right, finally we get x to be 3. It says, hence obtain A inverse. Hence. Okay, since we know what is x now, and so we know that A inverse is going to be equal to 1 over the determinant of A times the adjoint of A. That's going to be A inverse, 1 over the determinant of A times the adjoint. Now we already know A inverse. Remember we said that, we mean the determinant of A. We said that the determinant of A is this, minus 5 plus 4x. That's the determinant of A, minus 5 plus 4x. And so the determinant is really going to be minus 5 plus 4 times x, which is 3, so it's 7. So the determinant is 7. So the determinant is really 7. So it's 1 over 7 times the adjoint of A. So let's find out the adjoint of A. To find the adjoint of A, we're going to have to use a cofactor matrix. And then transpose the cofactor. in transpose the cofactor. That's going to be equal to 1 over 7 times. All right, so now we have this now, AB. Cofactor of 1 is going to be 0, 2, 1, 0. This is a plus. We have a minus here. And it's going to be cross out this and cross out this. That is 3, 2, 2, 0. 3, 2, 2, 0. Then go around here again. Cross out this, cross out this. So it's going to be 3, 0, 2, 1. 3, 0, 2, 1. Then crossing out the 3, it's going to be x, but x is 3. So it's going to be x minus 1, 3 minus 1, 1, 0. Then in the middle, it's going to be 1 minus 1, 1 minus 1, 2, 0. Then over here, it's going to be 1 x. So x is 3, 1, 3, 2, 1. Finally, down here now, it's going to be crossing out the 2. It's going to be x minus 1, which is 3 minus 1, 0, 2. Oh, and I forgot the sign. This is plus, minus, plus, minus, plus, minus, plus. So right here is going to be crossing out the minus now, crossing out 1. It's going to be 1, minus 1, 2, 0. Then finally here, it's going to be 1, x is 3, 2, 1. So now we have the cofactor matrix. So the cofactor matrix is going to work out to be 0 minus 2 is minus 2. This part is going to be 0 minus 4 is minus 4. Minus of minus 4 is 4. And here is going to be 3 times 1 is 3 minus 0, that's just 3. 3 times 0 is 0. Minus 1 is plus 1, but then the minus make it the minus 1. We have 1 times 0 is 0. Minus 2 is positive 2. Then we have 1 times 1 is 1. Minus 3 times 2 is 6. 1 minus 6 is 5. 1 minus 6 is minus 5. So minus 5 is 5. 3 times 2 is 6. So we get 6 here. Over here we get 0 minus 2. So this is just minus 2 here. Then finally here we have 1 times 1 is 1. Minus 6. All right. Just to make sure this column is right, crossing out the 1, it's going to be 1 minus 1, 1 minus 1, 3, 2. So this is not, this right here should have been 3, 2. Sorry, 3, 2. And here should be crossing out that, it's going to be 1, 3, 3, 0. 3, 0. All right, that should be fine now. So this shouldn't be minus 2. This is 2 minus 3. So this is negative 5. Then 1 times 0 is 0. 0 minus 3 is minus 9. And then we transpose this. So now we can write what is A inverse. A inverse is 1 over 7 times. When you transpose it, you're going to get minus 2, minus 1, 6. This looks like 4, 2, negative 5. Then you're going to get 3, 5, negative 9. Nice and easy. Soft. Now we can go to the final question on the paper, which is question 6. Question 6 says, show that the general solution of the differential equation y prime plus y tan x sec x equal y sin x plus c cos x. So you have y prime plus y tan x that's equal to sec x. So this is a first order differential equation. So when you have a first order differential equation, first thing you need to do, step 1, find your integrating factor. Your integrating factor I like to call it I, integrating factor is e to the integral of tan x. Now when you integrate tan x, you get ln sec. So the answer works out to be e to the ln sec x. But e to the ln, e cancel ln, and so you just get sec x. Now when you get sec x, you don't done your sum. What you have to remember is that when you get sec x, you're not finished. You have to remember now, the second step is you're going to write that the general solution is y times the integrating factor I is equal to the integral of sec x times the integrating factor. So it's equal to sec x times your integrating factor of sec x. And you're integrating with respect to x. All right, nice and easy. So what we're getting is y times sec x is really y over cos x, because sec is 1 over cos. So y over cos x is equal to the integral of sec times sec is sec squared. So we'll get sec squared x. Now when you differentiate tan x, you get sec squared. And so when you integrate sec squared x, you get tan x. So you get tan x plus some constant c. All right, and so this is y over cos x. Now you want to make y the subject, so you're going to multiply through by cos x. Multiply through by cos x, you're going to get y is equal to tan x times cos x. Y is equal to tan x times the cosine of x plus your constant c times cos x. All right, nice. Now we're almost finished. Almost, but not quite. Now one thing we need to realize is that, remember what is tan x? Tan x is equal to sin x over cos x. All right, that is tan x. Tan x is sin x over cos x. So if we cross multiply up here, we see that tan x times cos x is sin x. So tan x times sin x is equal to tan x times cos x, tan x times cos x is sin x. Tan x times cos x is sin x, just by cross multiplying. So since that is what we get, then we can resubstitute right here now. We can resubstitute for tan x cos x as sin x. And so what we're getting is y is equal to tan x cos x, which is sin x. So y is equal to sin x plus c cos x. Nice and easy, soft. So right, shown. What's the next part? It says, hence obtain a particular solution where y is 2 root 2, 2 over root 2, and x is pi by 4. So it wants us to obtain a particular solution. So we just found that y is equal to sin x plus c cos x. Now all you're going to do is find what is c. So when x is pi by 4, y is 2 over root 2. So 2 over root 2 is equal to the sine of pi by 4. I don't like to write so much pi, so I'm going to write 45 degrees. The sine of 45 degrees plus c times the cos of 45 degrees. Now, the sine of 45 degrees is sine 45. I think that's root 2 over 2. This is going to be root 2 over 2 plus cos of 45 is the same thing. It's root 2 over 2. So it's root 2 over 2 times c. And then over here we have 2 over root 2. So now we need the denominators to be the same. So I'm going to multiply this by root 2. So I'm going to write this as 2 root 2 over 2. So this is the same as 2 root 2 over 2. Now when the denominators are the same, I can equate the numerators. And so I have 2 root 2 is equal to root 2 plus c root 2. And so if root 2 is equal to plus c root 2, then c must equal 1. Therefore, c must be equal to 1. If c is equal to 1, then the specific solution then is y is equal to sin x plus c cos x. C is 1. Nice. Let's look at part B now. So right here we had, all right, so now finally we're at the last part of the question. We're looking at part B, and part B says a differential equation is given by y double prime minus 5y prime, and that is equal to x e to the 5x. And in order to solve this differential equation, step one is to solve the auxiliary equation. So step 1, solve the auxiliary equation. Find the roots of the auxiliary equation. So the auxiliary equation will be, I like to call it u squared minus 5u and that is equal to 0. So if we're solving this, what we're going to get is, this is then going to tell us then that u is equal to 0 or u is equal to 5. Once you get the roots of the auxiliary equation, step 2, that allow you to find the complementary function. So the complementary function, generally you see people call it YC. The complementary function is equal to, let's call it, it's equal to PE to the U1 to the U1x, so it's going to be PE to the 0x plus QE to the 5x. All right, so in reality, this part is going to simplify up to be that the complementary function is given by P times E to the 0x is just P, so that's just P plus QE to the 5x. Now, the second part now is to find, step 3, we need to find the particular integral. So to find the particular integral, let's do that on a fresh page. We need to find a particular integral, EI. Generally, people call it YP. All right, in this case, to tell us what the particular integral YP is. So since they gave us YP, we can find, so let's write it around here. They said that YP is equal to AX squared e to the 5x plus bx e to the 5x. All right, cool. So once you have the particular, integral yp, what we need to do is find the first derivative now, which is yp prime, and that's going to be equal to, we have to use product rule. Using product rule, we keep the first, which is ax squared, times the derivative of the second. The derivative of e to the 5x is 5e to the 5x, plus, you're going to keep the second now, keep the second, which is e to the 5x, times the derivative of the first. The derivative of ax squared is 2ax, plus, we're going to go ahead now and differentiate this. Differentiating bx e to the 5x, we keep the first, which is bx, times the derivative of the second, which looks like 5e to the 5x, plus keep the second, which is e to the 5x, times the derivative of the first. When you differentiate b times x, you just get b. So all I'm going to do is write out this a little bit better. So yp prime is going to be 5 times a is 5ax squared e to the 5x plus, this can now be written as 2ax e to the 5x plus, this can be written as 5bx times e to the 5x plus be to the 5x. Nice and easy. So that's what we have. Now we need to find the second derivative. To find the second derivative, it's going to be yp prime prime. And when we find that, that's going to be equal to, differentiate this using product rule again. So we keep the first, which is 5ax squared, times the derivative of the second, Derivative of the second is 5e to the 5x plus, we keep the second, which is e to the 5x, times the derivative of the first, and the derivative of the first is going to be differentiate 5ax squared, that's going to be 10ax, plus, we're going to differentiate 2ax e to the 5x, we're going to keep the first, which is 2ax, times the derivative of the second, which is e to the 5x times 5. So I'm just going to put 10 plus keep the second times the derivative of the first. Derivative of the first is going to be 2a e to the 5x plus, now to differentiate 5bx e to the 5x, that's going to be keep the first times the derivative of the second. 5 times 5 will give us 25 bx e to the 5x plus keep the second, which is e to the 5x times the derivative of the first, which is 5b. So this is really working out to be plus 5b e to the 5x plus the derivative of b e to the 5x is just 5be to the 5x. So if I were to simplify it now, I would realize that yp prime prime is actually equal to, I'm just simplifying now, 5 5 is 25, that's now 25ax squared e to the 5x, then this is going to be plus 10ax plus a 10ax, I'm going to write that as plus 20ax e to the 5x, then I have plus 2a e to the 5x plus 2a e to the 5x plus 25 bx e to the 5x, good, plus 5b e to the 5x plus 5b e to the 5x is 10b e to the 5x. That gives us the second derivative. Nice and easy. Now what are we going to do next? After we get this now, well, let's look back at the question. Y double prime minus 5y equal x e to the 5x. So first we need to find out what is, I'm going to do it in another column. We need to find out what is yp prime prime minus 5yp prime. If we work out what that is, that will give us, so pretty much if we were to, I'm going to do it in green, if I were to multiply this by 5, if I were to multiply this by 5, then this would become 25, then this would become 10, and this would become 5 times 5 is 25, and this would become 5. All I did was multiply through by 5. Good. Now I'm able to subtract them. 25 minus 25, that becomes 0. 20ax minus 10ax, that just works out to be 10ax. So I get 10ax e to the 5x. All right, cool. 25bx e to the 5x minus 25bx e to the 5x, that cancel each other. All right, and so what I'm left with is 10ax. All right, what else? Now this right here, which is 10be to the 5x minus 5be to the 5x will leave me back with 5be to the 5x. I will leave me back with 5be to the 5x. And I think I have, what else is left back? And I have plus 2ae to the 5x. And of course, the question had said that all of this is equal to xe to the 5x. So we can write that around here, that this is equal to xe to the 5x. Nice. Xe to the 5x. So now we can use that and set up our two equations to solve for a and b. I want you to observe that. Look at this. What are we saying? We're saying that if you underline this, you have 10ax e to the 5x is xe to the 5x, and then you have 5b e to the 5x plus 2a e to the 5x. That part must equal to 0. All right? So we can continue around here now and write those two equations down. But it must be that the 10ax e to the 5x, 10ax e to the 5x, that must be equal to xe to the 5x. And so if we divide through by e to the 5x, we're getting that 10a is equal to, divide through by x e to the 5x, we get 10a is 1, and so a is 1 over 10. All right, now that we get a is 1 over 10, what else we need to find? We need to find b. Now 5e to the 5x plus 2a e to the 5x must equal 0. That's the second equation. That 5a e to the 5x plus 2a e to the 5x, 2a or 2b, 5b e to the 5x plus 2a e to the 5x. This is supposed to be b. Change that to b. And you might wonder where the 0 comes from. The 0 actually comes from, it's actually saying that this is equal to 0 e to the 5x. That's where the 0 comes from. You might say, how did I come about the 0? Remember, all of this is equal to x e to the 5x. X, you group in like terms. If 10ax e to the 5x, these two terms have the x times e to the 5x. These two terms don't have the x times e to the 5x, and so it must equal to 0 times e to the 5x. So that's how this equation come about. We can then divide through by e to the 5x to get 5b plus 2a is equal to 0. And if 5b plus 2a is equal to 0, then we can make b the subject by getting that 5b is equal to minus 2a minus 2 times a, and a is 1 over 10. And then we can divide through by 5, and so b is going to be equal to, this looks like minus 2 cancels to become 1, canceling that to become 5. Doing division, this works out to be 1 over 5 times 5 is 25. So a is 1 over 10 and b is minus 1 over 25. So that means we know our particular integral then. Our particular integral is going to be ax squared, and a is 1 over 10. So now our particular integral is 1 over 10 x squared 1 over 10 x squared e to the 5x plus b, and b is minus 1 over 25 minus 1 over 25 x e to the 5x. Now again, this is not the answer. We don't finish yet. So now we need the general solution. You have to remember that the general solution is equal to the complementary function plus the particular integral. That's the general solution. And so finally, we can write that y is equal to the general solution, which is p plus q times e to the 5x, p plus q times e to the 5x plus yp, and yp is 1 over 10 x squared, 1 over 10 x squared times e to the 5x minus 1 over 25 x e to the 5x. Nice and easy, soft. This is the solution. All right. And so we have come to the end of this paper for 2014. Do see you soon, and just make sure to subscribe to the channel, and all the best prepping for your exam.